So we're going to talk about Omniverse. Omniverse is the thing that NVIDIA has been advertising in all its latest presentations so far. It's their big thing when it comes to software. This is what they're trying to push to all the developers, artists, anybody in the field of developing apps for the digital world, for metaverse, anything like that. I want to introduce myself as well. I'm Leonardo Gavert. I'm a software engineer senior at Arthrex. We'll let you know that Arthrex is hiring. Go over that in the end. So you might want to look into that.
Over there.
Oh,
Yeah.
Okay, so Omniverse is an engine that could be used in many industries. So Omniverse digital twins, for example, are solving some of the biggest problems. They're being used for wildfire simulation, Earth simulation, creating a twin of the entire Earth so we can predict climate change and other things that happen on Earth, like hurricanes, things like that. It's also used to create the factories of the future. So before you build a factory, a lot of the times when we build factories today, in the process, there's a lot of mistakes that are made, and those cost millions of dollars. So what the future vision of using Omniverse is you'd be able to simulate a factory before you build it, and every way that it works, so that engineers can get together and make decisions about what's going to be in the floor, what the operations are going to be like. And by the time they built it, they've tried it so many times that it's very unlikely that it would fail. So that's one of the things Omniverse is going to be used for. 5G signal propagation. So this is something that's interesting. 5G, something that's coming, and it's going to be huge. And Omniverse can be used to visualize the areas where the 5G signal, you'd be able to access it. You know, what would be the best structure or places to put your antennas and things like that, so that you can create this infrastructure and everybody can have access to it from ideal places. And robotics, Omniverse has Isaac Sim. Isaac Sim is an application in Omniverse that it's used to simulate any robotic behavior. It's used in factories and robots in factories, warehouse, and any scenario you want to build your robotic logic for Isaac Sim, test it in Isaac Sim, and then build your actual robot. You don't want to start in the field again. You'd be spending a lot of money. Do it the other way around, because you're going to fail. It's what happens in most times in the industry. And they also have the driving simulation. This is their solution for. There's many driving simulations out there. Tesla has their own engine as well, but Omniverse provides its own solution for driving. We also have modulus. So there's other ways to simulate the factory of the future. So they do a lot of industrial simulation to be able to have all the processes that are used in the industry in a virtual format. So if you want to make modifications, it's not going to be costly. It's not going to be something that's going to cost a lot of money when you actually build it. And the final one is the virtual agents, creating digital avatars of people, creating digital humans that you can interact with. For business, this is a huge thing, because that's somebody you're paying for. Typically, if it's in a video format, you'd have this more human-like experience when you're interacting with software and services that are provided to consumers, which at the end of the day, they're used to dealing with humans. So that's something that's going to be huge. Next slide. So here's a collection of the Omniverse apps. It might be a little small, but I can go through them. I just wanted to show all the vast amounts of apps that are available for Omniverse. Omniverse is a collection of applications into one software package. So if you've seen launchers of other types of applications, that's along the lines of what Omniverse really is. Every time the NVIDIA refers to Omniverse, it's really difficult to kind of track what they're referring to, because sometimes they're referring to the cloud service. Sometimes they're referring to the actual app on the desktop. So the launcher is really the best way to describe it because it's the one thing that gives you access to all of Omniverse's tools. But really what happened is that NVIDIA had all these scars, all these applications they had built, and they were all spread around. They were in repos, some of them were in engines like Unity Engine, Unreal Engine, and they had some of them that were just standalone applications. And so instead of having this massive collection of apps everywhere, they said, hey, we're going to create this one thing that's going to bring it all together. And that was Omniverse. So in reality, a lot of those apps are not directly integrated into one software application yet. They have these things called connectors, which is what we're going to go into next, which is what brings all these applications together. It's a way to connect from different applications. But really, it's a launcher for a set of applications that NVIDIA provides. The main applications they provide is Omniverse Create. Omniverse Create is very similar to something like your traditional game engine, like Unreal and Unity. It's something where you can bring in assets, you can manipulate them, you can use some of the other features from the other apps to modify those assets and create a real-time ray traced application. So Isaac Sim is another one of the main applications they have, which is for robotic simulation. For people, it connects with a lot of the software, engineering software where robots are created, and you can bring those designs from those software, like Inventor and things like that, straight into the software and create a simulation to use your software before your robotic arm, let's say, before you actually create it. And View is the top of the line, the highest end form of visualization tool. It's a rendering engine in real time where you can bring in models and see the highest level of quality NVIDIA can offer in one application. So before they had View, they actually had this render in like a GitHub repo that people had to go there, download it, compile it, run it. So they created View, and now that's a replacement to what Unreal and all these other engines did by taking that GitHub repo and incorporate it into the engine. So this is real-time ray tracing, all the NVIDIA features, RTX, trying to think what else, physics, element simulation, everything you can see in View. And then they have code, which is for the programmers. This is the application that you use to write code that connects all these applications together and that can be reused in these applications. The programming languages that they use, C++, Python, most of their, the stuff they work with is research papers, research code. So a lot of that is written in Python typically, but the core of the engine is built in C++, and you can still have access to C++. And they want to expand that to include other programming languages for people who are more familiar with things like Unity, C#, web languages.
So is that like an IDE? Like
Yeah. That's the thing. The code editor is like an IDE, but it's interesting because it's something that connects. It's something that connects all the applications. It's not intended for any particular use. You can't really use it without the application you're developing to connect one of these applications. So yeah, it is like an IDE. And then below that, you have all the apps that they provide. So for example, one that was recently announced was Audio to Face, which is the first one that shows up here. So it's this one right here. I don't know if you can see the cursor, but I'm going to go through some of these, the main ones that relate to VR and AR. But Audio to Face is being used right now to add voice to digital humans. Another big one is the XR. We're going to go through that one, Omniverse XR. So I'll talk about that one in a second. And another one I want to cover towards the end is the Kaolin, which is it allows you to generate synthetic data, but it's very useful for artists as well if they want to create models, or people who are not artists as well. They want to generate models to create digital experiences and they don't have the skills, they can use AR. All right, yeah, that covers that. Okay, so then this is the collection of connectors, and I wanted to include all of these so you get an idea. These are pretty much almost all of the ones that they have, but they have a lot of connectors to different applications that are standard throughout the digital virtual worlds and digital content creation industry. So they have 3ds Max, they have Maya, Designer, so many out of Adobe products, Unreal Engine, so different engines, different 3D software. They really cover everything, including Blender 3D software as well. So these connectors are applications built in using code in Omniverse to be able to bring assets and logic from any one of these applications into Omniverse. So if you created a 3D model, the connectors would create a plugin, say for a Blender or any other software that would make it very easy for you to send your models and the work you've done, your scene, from that software to Omniverse, so you can utilize it there. You can modify it.
Like an API.
Anyway, yeah, but it's like a plugin. I would think it's more of a plugin that there's many connectors like this for other applications. But the beauty of this is that that connector can be modified. It's available for modification. So if you have something custom that you want to add to this connector for something that doesn't do currently, it's available. It's open source. It can be extended. So that's really awesome. That's one of the great things about all these connectors. And also it separates the engine itself from how it connects to all these applications, meaning if something goes wrong there, then it's the connector that you have to worry about. You don't have to think, well, they have to update the whole engine to make my application work, my application connect to Omniverse. So the first thing, let's see that. Okay, so the first thing I want to talk about is the XR features. These are, group was probably most excited about is you have fully ray traced VR. This is something that you're not going to find in any other application, because ray tracing is something that's built into the hardware of this GPUs, but needs to be implemented into a lot of these applications, and it requires custom implementation. So if you want to do this in a game engine like Unreal or Unity, or even if you want to do it on a web XR application, there's just no implementation of it whatsoever, because it's very low level. You have to talk directly with the CUDA APIs on the GPU, on NVIDIA ray tracing GPUs. So they already have that built into the software. So you have this fully ray traced VR experience that you can launch from Omniverse with like a press of a button. And that's through this application called Create XR. This is one of those applications that we saw at the beginning. So Create XR, it's a fully VR application that supports AR and mobile devices, and so it could be on a tablet or a phone, and it also supports VR headsets. So if you want to display something in a VR headset, so you would think, well, how can we get fully ray traced, beautiful graphics on a mobile device or on a tablet, right? That's not really possible today. So what this does is it streams the application from either a server or a desktop computer that has the capability to run the visualization, the high-end graphics, into a cell phone or a tablet, which is lower end, it wouldn't be able to run those applications. And not only does it do that, but it can also do that with multiple people in the experience. So one of the things that it has is multi-user interactions. So multiple users can be in an XR application looking at a beautiful high-end model from an iPhone experience or a tablet or even a mobile VR headset like the Oculus Quest. And another thing they have, as one of the samples, they have many samples that are available when you open Create XR, just the engine comes with those samples, is that they have auto-generated nav mesh. So because they do ray tracing is one of the things that is very useful for generating navigation, because ray tracing gives you where a ray hits the surface, so you can tell what's the floor and what's above the floor. So that can be used to generate navigation in an environment. So you bring, let's say you take a 3D scan of a real world environment and you want people to visit that 3D world environment, you want to take time figuring out what the navigation is. You can use the ray tracing features that NVIDIA provides to generate the navigation mesh. And yeah, the other main thing is streaming the 3D data to any sort of application. So it's not only your phone or a tablet, it could also be an application that you've created. You can stream the 3D data straight to your application. It can be hosted in the cloud, so this application can be running on your desktop, or it can be running as a cloud application. There's a video I embedded, but I'm not sure.
Can you pull up that thing? Maybe it's blocking it. The video, maybe load it up just a screenshot. Maybe.
I exit the. Let's see here.
Oh, yeah, just a screenshot.
Okay. That's okay. So I will show. So I wanted to show a video of Omniverse running. I guess we can find one later online.
Yeah,
There's but here's some of the connectors. You have engines like Unreal and Unity. There's connectors for those. And there's also modeling and animation tools like Blender and Maya and Enthusiast Max. So these connectors for the modeling and animation ones, you can take animations that you created if you're an artist in these tools, and you can send them over to Omniverse. You can modify them and visualize them, and also bring them to the Cloud XR application, so you can see them in XR. Same thing with Unreal and Unity. You can take content that was created in those engines and bring them into Omniverse and visualize. And so the next thing I want to show is how pipeline would work for somebody who's already familiar with developing either 3D, or even if you're not familiar with it, if you wanted to know, okay, how do I go from just having a 3D model, modifying it to create the visuals that I want, using Omniverse as part of that pipeline. So you start in a 3D software to create a model, or you might scan it using your phone or something. There's plenty of apps that you can scan. So if you don't have those 3D art skills, you can always scan with your phone. And then you bring it into this 3D software, you modify it, like you cut out the part that you want, or if you create it, if you have the 3D modeling skills. And then you can take that into Omniverse, and you can add physics simulations on top of that. So for example, one of the traditional use cases of physics simulations in the 3D graphics industry is that you have a tablecloth and you want to cover a table, and you want it to physically simulate how a tablecloth will fall on that table, right? So imagine you have your table model and you have your cloth, it's just a plane, but you want that to fall perfectly using the physics simulation, look like a real cloth would. So you can do that in Omniverse. You can't. 3D software like Blender, 3ds Max, and Maya 2, they have a lot of those features, but in Omniverse is real time. You can't do that in real time in any of those software, right? So that's something that's huge. Also, the quality of it is much higher because NVIDIA's physics simulation using their own developed GPUs is far greater, far better than a lot of the implementations in 3ds Max, Maya.
But the plane that we bring from 3D has to have enough polygons to do that, right? It's not gonna add polygons on top of it.
Yeah, right.
Will
So
it?
No, it won't
it's not.
necessarily. So, but no, that's just an example. Yeah, and it will have to have enough polygons to be able to simulate the proper deformation. But another example is, think of you have something that you want to break. Something that needs to break into pieces. You want to simulate how something would look if I don't know, a hurricane hit it or something. You can take it into a physics engine and see the physics of that. So there's a lot of advantages to having physics engine. Or you're designing a car and you want to see how your wheels in your car are gonna interact with the pavement or something. and you can simulate that in physics. There's also ray trace materials. So if you have all these models, you created them, they're beautiful. And a lot of these 3D softwares, getting a beautiful render takes a lot of time, and it takes lighting artists, people who are specialized. You can just bring that and get the ray trace materials from Omniverse, which are supposed to be lifelike. They're supposed to, they use this ray tracing. It's the same method that is used to recreate real life lighting. So it's the same way physics works. Rays are casted into objects, and then you see the light comes up off of them. So you can use the ray trace materials that Omniverse provides to create a real-time render, something that looks beautiful immediately on the fly. So if you have a model that you've already built and you just want to drop some materials on it to see how it's going to look, you want something reflective, something shiny, you can just bring it into Omniverse. It's going to make it a lot faster than using any of these 3D softwares. And the other one is fluid simulation. Imagine you're simulating a fire in a building. You have your building, you bring it into Omniverse, and now you want to use fluid simulations to light it on fire and see how it reacts. And then you can combine some of those features like the physics to see your building crumble.
So you like literally giving like qualities of the liquid, like telling what liquid it is, right? The chemical consistency probably, and then like
so they have
fire.
presets.
What I mean.
They have presets, and you're using one of those presets. But yeah, a lot of those presets are fire, and then they have those properties.
Yeah.
And the beauty is that you can also bring in. There's people who are doing research that have those level of details and parameters, and you can bring those into Omniverse because it's the connector of all those things. So you can bring a lot of those research projects, and if you want to utilize that, Omniverse would be the place to do that. And from a programming perspective, they try to make it very simple for you to integrate with any of those software that are created for simulation and things like that. And then the last one is AI content generation. So NVIDIA is the one that creates the servers that are used by OpenAI, and they are the foundation of all the hardware for AI that is used today, at least the main one. It's all GPU based. And so they have the best tools for AI generation. We presented in the past a bunch of tools. They're really amazing. You can create 3D models, you can create 3D art. And some of those tools are in Omniverse. So you can bring your 3D model, and if you want to enhance it by adding something on top of that, you can use the AI content generation to improve your model or add additional models to what you already have. And notice I have this arrows going back and forth. So once you're done with that, you can send them back into your traditional 3D software and keep editing it in that 3D software. Another connection you can do, if you want to keep going after you did all this, you can take it further and take it into your engine. And now you can add, for example, characters. You can use the MetaHuman tools from something like Unreal Engine and add characters to the simulation that you're creating. Or you can use the control rig to animate something happening in the simulation that maybe the physics simulation didn't cover. And you can bring engine-specific features. You can imagine if you're using Unity engine to use, you're very specific to that. And then from there, you can go back to Omniverse. Once you have, let's say you have your building, you have your avatars, your characters inside this building. Now, the next step is go back to Omniverse and use audio to face maybe to animate your characters and bring voice to them so they can, I don't know, guide through an experience in the simulation. Or you can bring it into Create XR and have an XR experience where you see this in VR and VR headset, and you see it with real-time ray trace shadows. You can also bring other people into that experience. So you can think of somebody like an architect who really benefit from bringing it into Create XR, because now they have their model, they brought into Omniverse, they showed the physics, they brought some digital characters to walk around to show how people would utilize the space. And then finally, they bring it into Create XR where they can show it to other clients or even teammates, and they can discuss if they want to make additional changes, all within Create XR. It's to scale because it's in VR. Or if you want to do it in AR, it would also be to scale, but it's overlaid on top of the real world. And on top of that, you have the ray tracing. So you have the highest quality visuals you can have. Any questions here? Anybody? Questions on the pipeline?
Let me just quickly, any questions here?
It's all new to me, so.
John says, often is on the cloud processor time is put by a server.
Someone asked the type of pricing that they have with the Omniverse, and I too am interested in how that works, enterprise level or what have you.
Yeah,
with the Omniverse, or whatever it's called.
yeah, they have a free tire, but they also have an enterprise level tire, which is far more expensive.
Yeah, the enterprise, what was it?
Well, I'm
You
not
don't, not
sure.
sure, it's expensive. But they do have like free one, up to 3 people in the
Yeah.
team.
Even for Create XR, if
yeah.
you want to bring people in VR and look at, they have a version that's free up to 2 people. So that's pretty good. The cloud version, you could try it as well, but I mean, there's still a cost because they don't give you the cloud access for free. You would have to try it in your own cloud. So you
Yeah.
host it.
Heard by any chance of the NVIDIA Jetson series or the Nano series of Jetson modules that that run Ubuntu and are essentially AI specific? Would that be compatible with this sort of system of the Omniverse? Do you have any idea? They're little board weight like Raspberry Pis that you just kind of plug in, and I'm wondering whether it would have the capacity or possibly not.
Yeah,
as
so
a server terminal.
Omniverse runs on Ubuntu, a Linux application, so it would run on a Jetson, no problem. And the problem is the capacity of it would be what type of applications are you trying to do? But for example, if you're trying to train, I don't know, you're trying to do a robotic simulation that eventually will be used with a Jetson Nano anyways, you might want to run the simulation first straight on the Nano and actually use it with the robotic machine.
Okay, I see. It likely would have been something conversational like GPT sort of orientation, but with a little bit more of a back and forth to it. My business itself is Tangential LLC, which is currently going through closure, but nonetheless was as is goal setting using AI. So that's the idea of it, and I'm just trying to get a more solid position with more money in it than my personal business. But in any event, I just wanted to express my appreciation, of course, for the presentation. I thought it was very well done. So if that's wrap up, then it is. Thank you. I have to go though. Sorry.
But yeah, this could be run on it's Ubuntu based. So you can run it. There's containers for Omniverse as well. So if you want to run it on the cloud, if you want to run it on a device and smaller device, there's really they really built it as a launcher or a container for all these applications. So you wouldn't get all the features necessarily. For example, I'm sure the VR wouldn't necessarily run on a device like the one he was mentioning, Jetson, but some of the other connectors that do support those devices, some of the other applications that support that, they would run on the Omniverse engine, but the engine itself does run there. It's just what applications it would support. Okay, so I wanted to show a little piece of the workflow videos so people could understand the workflow.
The Unreal Engine Omniverse Connector plugin is essentially a way to access the Omniverse ecosystem. First off, you can add a Nucleus server to your Unreal project. This gives you access to your server files directly within the content browser. They're stored under a folder called Omniverse. With access to the Nucleus server, you can directly use NVIDIA library assets within Unreal. Double-clicking the USD opens it. It also distills the MDL file, meaning it translates the materials into something Unreal can use. Let me open another USD. When you open a USD, you can also edit it. In this case, I'm putting a new material from the NVIDIA materials library, also accessible through the Nucleus server.
I just want to stop here. So this Nucleus server is something that you can access through Omniverse. It has a ton of resources for people who maybe you're just trying to test something out and you don't really have the art, you can use the art from the Nucleus server. You can use their materials. So this is what I meant with maybe you just have a model created and you want to add materials to it. You can just focus on the materials, but if you don't have anything, you can always just use their assets for whatever type of simulations you want to do, or whichever the application might be.
The Omniverse layers panel gives you insight into the USD layers and also lets you save the changes you make back to the USD file directly. When you right-click on a USD, you are presented with the Import USD option. This converts the USD file into Unreal's native asset format, meaning you can use this asset the exact same way you were used to working in Unreal. And you don't need to just import assets. You can import entire scenes, like this one. This room was created in Omniverse Create by Andrew Aberkin and imported into Unreal Engine. This room looks pretty clean, so let's populate it. I'm going to speed this up a bit. The eyes come from Nucleus, and you can apply.
He's gonna populate the scene. This is in Unreal, so this is not Omniverse yet. This is in Unreal, and what he's gonna do is he's gonna create a scene. And the part I really wanted to show was the process. So you would create a scene in whatever application you want. You can even do it in Omniverse. But if you were familiar with another application, so you can imagine there's like even web applications that could be, where you could create 3D environments, right? Okay, so he's just creating a scene.
Have a link to that video.
Since the OmniStage actor was pointing to
There's a link in the slide.
Okay.
Well, so now this is Omniverse.
Omniverse layers panel. Since the OmniStage actor was pointing to a USD in Unreal that we dropped items into, we can open this file and create. One of the most unique advantages of using USD with Omniverse is live. Now I can access the NVIDIA asset library and material library even easier. See how everything is instantly populating between the two applications? And this is where the NVL distiller really comes to play, changing all of those materials to something Unreal Engine can't understand.
So I want to add something here. If you're building, say, your own application, this connector is available. So you could connect Omniverse to your own application. So you can use Omniverse kind of like the designer for your own application to like move models and all those things using the connector. So it would understand whatever the language of your own application is and how you move models within that application. So it doesn't have to be Unreal. This could be, this is the same workflow for a lot of the other connectors.
I don't know if you want to, speak on it a little later or not, but the coolest thing for me is that like you can work in Unreal, I can work in Unity, somebody's working in Blender, and all we see and create, we can all have a connector to create. And we see that in real life, like what I'm working on, I can see what they're working on, and it's too different because I don't have Unreal skills, but I have Unity skills. And they hire me and we all have the same project we're working on, right?
Yeah, with this connectors,
With the connector.
So if someone's using Unity and Unreal,
Yeah.
you just need that box.
Mhm.
Make it easier.
Yeah, so
And then-
this, you could be connected from this same app to Unreal. You could also be connected to Unity at the same time.
Oh, my,
And the thing is that
Omniverse.
Omniverse, which is something I was gonna get to a little later,
Sorry.
Omniverse has the possibility of multiple people collaborating at the same time in the application, which most applications don't have. So you could be in the same scene, moving things around. So that's what she's referring to, is where you could be, and you working on your computer, where you're working in Unity, right? But somebody else doesn't have Unity skills, but they're using Omniverse, and Omniverse can connect multiple people. So somebody can be working in Unity, connected through Omniverse with somebody that's working in Unreal.
And
So I
here
just
we
wanna-
merge the live changes down to the original USD, creating a truly non-destructive workflow. There were also some new assets I want to get over to modify and create. You can export an entire level to Omniverse, but we're going to select the items I know I want to edit in this case. Now that we exported these items, I can actually turn them off in Unreal, since they will be represented as USDs. I'm going to add them in as a layer in our base USD file and save. Now you can see that we have everything back in Unreal again. There are some other items that I know I will need to interact with, more like reference items. I'm going to export those as well and add those in as a layer. We don't need materials for those since I'm only using them as reference. Now we're all set up. The purpose of connectors in Omniverse is to let the user use the right application for the job. In this case, I'm going to be showcasing some cool tools and physics in Create to populate our Unreal scene. Use physics to drop the books on the shelf. You can line up some dominoes using the Ray tool and run some physics simulations to get them to drop.
Yeah, so what you saw there that he just did with the physics simulation, that's not something you can do in Unreal. But this is because it's bringing that physics engine that Omniverse has. Now, this is something you can do with any software that connects to Omniverse.
The randomizer helps vary the Legos. Then we can drop them and sweep them around with physics taken into account. I'm going to exit live mode. We're going to swap these instanced assets. Since USDs have references to other USDs, I can open the file that contains the instances and swap them out with something more fun. Now, back in the base file, we can see they are swapped. And we can use the paint tool to straighten the instances out. When we save, we can see it's all populated as expected in Unreal. The room's looking pretty cool.
All right, I just want to show one last thing. Oh, here we go.
And this is really cool. This was modeled with a bunch of separate components. So if we turn on physics and drop,
Right, so
very cool way.
that's almost like a Lego set, and he has the full model with all the components. He turns on physics, and it just like it wouldn't in real life, it just drops and breaks the pieces, right?
So you could break a glass of water
Yeah.
and just that water will
Yeah.
drop in the glass.
You can specify the thickness and everything and material, what type of glass it is, and it knows like it's already connected on the physics level.
Mhm.
Yeah.
Yeah, so-
Even boiling water, like you can tell what like degree of water it is, because the hotter it is or like the colder it is, it reflects water different way. So it will understand and it will calculate.
Yeah, it's really designed to be a simulator for enterprise and for like everybody, pretty much. Anything you want to simulate, you should be able to simulate it. It was a lot of these tools were created by PhDs, the scientific community, because NVIDIA works, they fund a lot of research at universities, and they brought it all into Omniverse. So they want scientists to use Omniverse as their, instead of using most people in the research, they would go and build their own little application so they don't have to worry about anything else, right? But they want to encourage people to use Omniverse as the engine to do those kind of simulations.
Can I add something before I forget? I don't know, again, maybe you can use it. Same. You have to have NVIDIA RTX card though. Like you have to have an NVIDIA graphic card to be able to run Omniverse. Doesn't run just on Mac.
Yeah, that is one of the requirements. But if you have a cloud service, you
Oh,
can
cloud
just
service.
use it costs though, it costs money. It's not free, but
How much?
it's a subscription, so you have to pay for how much you use it, or they have different pricing plans.
It says, Anil is asking, so is it real world physics?
It's supposed to simulate real
Yeah.
world physics, yes. Yeah, the link to the video will be provided with the part. Okay, so here's another example use case. Omniverse uses it for character creation. So there's a company that they work with called Character Creator, and they have the suite of tools where there's animations, clothing, and character models. So if you wanted to create a virtual avatar or just a virtual human, you can use one of these tools along with Omniverse and using the USD file format, which NVIDIA originally created by Pixar, but NVIDIA has brought it to the mainstream, and USD is the language of Omniverse. Everything in Omniverse is turned into USD at some point. So you can go from a character creator where you could define all these values for your character by changing some sliders and making some selections, and creating a custom character, bringing it to the render and the simulator, so you get physics for your characters so you can interact with the world. And then you can take that, the physics you created, for example, for clothing, you can think if you want to test a new line of clothing on your virtual avatar, you would bring it here, and now you have actual physics simulation with the animation of the human. So they're making a certain movement, and you can see the clothing getting simulated, and then you can take that and send it back to any other software. We're here as some classical like 3D software that's being used, but this could be anything. This could be a web application as well, if it has to be, or a phone application. So if you have a shopping, think you have your shopping application and you want to show the latest design on a 3D model, you could generate your character, add the physics to the clothing, and then show it in your shopping application. Hey, here's the latest design.
You can take a picture of yourself and put it up.
And you know, if it has your actual dimensions, buying clothes online would be a lot better of an experience.
Yeah.
Instead of- If you have the AI, be like, can you change this?
Yeah, and that's another thing that this has. Powering is the generator, the AI generator, but they have other. NVIDIA is really powering everything when it comes to AI. They're creating the hardware, the servers that run all the AI models. So they have all these applications that work with Omniverse today, mostly on the graphics side of things rather than so image generators and things like that. But for what you're talking about, that's in the graphics realm. You want to see exactly what you're going to look like or what something's going to look like on you, and you want to make changes to it. You could just use natural language to express those changes and have the AI generate the image. And one more thing I wanted to show is they just showed this at
Yeah, I saw that.
conference.
Yeah,
It's really awesome.
today
This
was
is-
like everybody was just like, oh, that's this. And that.
Sorry.
Don't have to so be sorry.
I was
You
just
didn't put it
thinking,
there.
Amazon should get on that clothes thing immediately.
Yeah.
Yeah, they have a service called, I think it's Sumeria or something, but they're trying to do something very similar. Okay, so this, you can think of this as the future of characters in interactive media, video games, things like that. Digital characters.
We are thrilled to showcase an immersive and dynamic interaction between the player Kai and a non-playable character named Chen. This captivating ramen shop scene was created by NVIDIA using the latest RTX rendering technologies. NVIDIA collaborated with Convey, an NVIDIA Inception partner, to showcase how developers will soon be able to use NVIDIA Reba, Nemo, and Audio to Face for AI-powered speech, conversation, and animation. These models were integrated into the Convey Services platform and fed into Unreal Engine 5 and MetaHuman to bring Gen to life. Please take a look.
Hey Jen, how are you? Unfortunately, not so good. How come? I'm worried about the crime around here. It's gotten bad lately. My ramen shop got caught in the crossfire. Can I help? If you want to do something about this, I have heard rumors that the powerful crime lord Kuman Aoki is causing all sorts of chaos in the city. He may be the root of this violence. I'll talk to him. Where can I find him? I have heard he hangs out in the underground fight clubs on the city's east side. Try there. Okay, I'll go. Take care of the guy.
All right, so that entire conversation is AI generated. So the person is speaking through the microphone with the AI, and then the AI responding completely with generated responses, right? And that scene is actually available. I don't know if the character is available, but because that's something they just announced at Computex like 3 months ago. This is a demo they created. So it's going to be available at some point, but the scene itself is available in Omniverse. It's one, when you open the Omniverse launcher, there's a set of samples that you can look at. That's one of them, and it's physics. It has all the physics simulation. So when you move a glass in that scene, it has water on it, and it spills on the ground, all those things. So that's the perfect scene to look at if you want to check out what Omniverse can accomplish.
Imagine not being able to beat a game, you just beat an NPC map.
Or every time you play, it's different.
Yeah.
Yeah, every time it plays different. That's huge.
You put it full screen. Do that.
What? So yeah, that's the latest. So this, I just wanted to include this diagram to go more into detail to the development workflow. So there's multiple parts. One is you can create extensions to the existing features in Omniverse, but you can also create connectors. So the extensions are kind of connectors, it's the same concept, but it's specifically to Omniverse. You don't have to necessarily connect another application, but it uses even the same development tools that you need. So the same code, everything is designed to be used the same way, to be programmed the same way. So you can create extensions for the existing applications. You can use one of the applications that they have. Some of them you can't make extensions for because they're proprietary, like I think the XR is one of them. Those are the Omniverse kit based apps. So a couple of them you can't really, but then you can use the tools that they provide. They have a series of tools as well. And you can use their core technology, Python, USD, the physics engine, okay, and the ray tracing.
There's a question here. Is that cinematic shot
That's in Omniverse.
rendered in? Okay, that's
Yeah,
what
so the
Omniverse has.
reason you might think is UE is because it's using metahumans, but again, Omniverse connectors brings the metahumans from Unreal Engine to Omniverse. So that's why you're able to see that it's using, and then obviously they're using that because they don't have they have a character generator, but it's not full body, it's only head so far. So that's probably what they're not using theirs. They're using metahumans because that's a full body character generator. But NVIDIA also has, as part of the Omniverse, they have a full head and character generator. So, but it's just the head and the speech. Again, there's a set of microservices. All of this could be hosted deployed on a server, on a computer.
I have a quick question. Can I set up real life character creation using Omniverse in my application? Like people would be like customizing avatars and they will connect it to Omniverse.
Yeah, that's what this was.
The previous, this
Yeah,
one.
so Character Creator does that. It
Oh,
creates
wow.
character. So that's not an NVIDIA, but they have a
But they can
partnership.
connect it and then let users inside my application customize the character. Or I should do it before.
Oh, you mean like a real-time running
Yeah.
application? So I think you would have to build the application for that. So eventually you have to have it in. But you could, I see what you're saying, like real-time, they make a character. I mean, it does run on you could have a Omniverse deployed to a service, and you can provide that service to your users, but you'd still have to have maybe a Unity application.
Yeah.
Like there has to be an interface.
I will have.
They can't
that,
access directly the engine
Yeah.
unless they want to download the engine, right? But what you could do is you could have the Omniverse deployed as a
That's what I
server
was-
application, and then you give your clients the Unity application where they can customize the character. So
Yeah.
you're using Omniverse in the background and using all their generators in the background, but the front end application that
Yeah, for sure.
users are seeing are your Unity or your web application or whatever it is. So yeah, it could be deployed as a service. Right, and then it connects, it talks to all the microservices as well. They have multiple asset bridges. So if you have any type of asset format you have, including machine learning models, they have a bridge to take those machine learning models into Omniverse. Industrial assets, things like AutoCAD, Revit files, things like that.
Network with any cloud,
What do you mean network with it?
like AWS, GCP, like you had a free
Yeah.
model.
Yeah, I think,
Azure.
yeah, you can, yeah, you can deploy it to any cloud service because what they provide is a container, but I'm not sure is because you have to use NVIDIA GPUs, there might be restrictions to what service providers provide NVIDIA GPUs. So I'm not sure about that because I know they don't work with everybody. So it's not everybody's gonna have a.
But if you could, in your cloud provider, you can specify the graphics.
Yeah, so exactly. So if your cloud provider provides NVIDIA GPUs and they have that, you can deploy this. It's not tied to any particular cloud service. NVIDIA has its own cloud service too. So if you want to use theirs, they have a subscription. What I'm not sure about that also is because there's a license for using it in cloud, I don't know if there's restrictions to a license. Theoretically.
Yeah, I wonder if
it
you
could
could,
be
you
used.
probably could go through their marketplace and buy the license from NVIDIA, because they all have a marketplace.
Yeah, but you know, sometimes when they give you like a license for a software, they say, well, you can't use it with this service.
Yeah.
Because we don't want competitors. But I'm not sure, I haven't read all the details, but I know you get, it's a container or image, so you can deploy it, anything that it's a
Yeah,
Linux.
yeah.
Okay, and then, yeah, that covers, I don't want to get too deep into the development because it could get really complex, but that's just a basic overview of some of the areas that you can develop on. You'll have access to the PowerPoint. And the next thing is the real-time streaming option. So you can, like we were just talking about the cloud service, you can have this stored in all this data stored in your Nucleus. By the way, I just remembered something I didn't add in here. Nucleus, because it has that AI power, it also has a feature where it can tag your assets. So it can detect what type of asset it is. If you have a collection of images or 3D models or anything, or even audio, it can tag what it is and give you a name. So when you're searching through a large collection of assets, the AI already generated what categories it should be specified in, right? So if you have a collection of pictures and some of them are like car pictures, some of them are buildings, it will tell you, hey, these are car, these are building, even if you never organized them, you just took a bunch of pictures of different things. Right, so that's super powerful, and does that with models too. So it's able to do it with models as well. And so you can deploy Omniverse to a server, and then you can have a local workstation connect into this Omniverse application and stream the data from the Omniverse. So you can use Omniverse on a server. So there's real-time streaming to any type of device, whether it's on a web browser, augmented reality, virtual reality. All of it can be remote, or you can have a local workstation running. And you can do that on a service, on a server. You can also set it up in a local workstation and then have people remote from virtual reality or augmented reality as well, or other computers as well. Okay, and then the next big thing is Omniverse is trying to be the collaborator tool for anybody who's working in visualization. So just like I mentioned before, they have these cloud XR applications. They even have a WebRTC application to connect to the browser, but they also have a way to stream directly to each person's client what other people are seeing. So as you are modifying and doing things in an application, it can stream in that data to the other person's client. So it feels like everybody is working on the same scene, on the same project. Because it's all networked, and Nucleus keeps track of its data management database that keeps track of all those changes, and everybody can access it, right? So then you can connect your files from Maya, all these software to that database, so you have access to all the files you're working with. So their vision is that you're going to take your entire, if you're in the digital world creation or digital content creation, specifically something that requires RTX GPUs, requires any type of GPUs, you're going to take your entire studio to the cloud. That's their ultimate vision. So all you need is your computer to connect to the cloud, right? And then everybody else is connected and working together in the same project at the same time.
AR computers.
Yeah, or you're going to be on an AR headset doing your work. right? So you can imagine that's gonna be the future when headsets are really light and all the stuff, people are gonna be going around doing all their work in their headset.
Right?
Yeah, or call.
Just take it on charger.
It'd be pretty weird, just, what are you looking at? Okay, and yeah, this is another, just a visual they have that I thought was interesting. That showcases that artists can collaborate, everybody can collaborate into the same scene. Somebody can be working in 3ds Max on that bridge, somebody can be working on the tower, somebody can be working in ZBrush on that, and all of them, whenever you save, it gets saved to the nucleus and it updates in the scene. So everybody can be collaborating on their own projects, this is what you were talking about.
Yeah.
too, on their own software on one piece of this scene that's at the center. And it all combines in Omniverse. So Omniverse has all the changes in real time. So as an artist is working on modifying the pillars on that building, somebody's working on the textures for the building, you will always be able to open Omniverse and see the final result of everybody's work together. And you can imagine this is for the 3D artist pipeline, but it's the same thing for people who are coding or designing. You could be coding features. But I mean, in the coding world, you already have tools that do this. So it's more exciting in the artist world because that doesn't exist with 3D models. It exists with code, there's code paths for people to code together and all that stuff. But when it comes to visualizing objects and interactions, you couldn't really do that together with other people. You have to render in your computer and then take a video and show somebody else, or maybe do a share screen, and then share screen is low quality. But now you can just stream it straight to their browser, to the application, to the phone. Okay, and then I just want to show a quick example of collaboration in real time.
Experience Florida Course grand opening.
Okay. So I don't think this has any audio. Yeah, but this is just an example. These are all different computers. So all 4 of these are different computers. They have Omniverse open. Somebody down there is in Maya, working in Maya, but you can see the changes happening in Omniverse. You can see this little cube here. He's working on it in Maya.
So can you see that in VR? So something like a
Yeah.
screenwriter, you sit there and be
That-
like, no, fix it.
Yeah, that's another application. So you can have your developers working in the room in their workstations, and then somebody can connect in VR, who's maybe the project manager or something. And he could be like, oh, we need to change.
Someone just stands here criticizing everything.
Exactly.
Yeah, if you're working, it's like, huh, that's wrong.
Who moved this? But
Yeah,
you see
that's-
that there, is that that's Blender, the top one.
Yeah, so this one's Blender over here, so they're painting
And this is
protection.
like Maya.
This is
and
Maya.
Maya.
Yeah, this is the.
Or you can also have Photoshop too. So
Yeah,
somebody
this
would
is
work in
Unreal
Photoshop.
over here.
Okay.
Yeah, so this person is in Unreal. So I mean, this is the full pipeline. If somebody's on Unreal, maybe Unreal's the final application that they want. Somebody's working on textures, somebody's working on the model. Yeah. and
For me,
then-
this is the coolest part because it just, when you work in this field, there's so many little changes, there's so many little things, and you just like collaborate together and save it. And also USD now, they like big metaverse is not now adopting USD as like the file format for the metaverse, which is really cool.
Yeah, you can imagine the coder too, programming the logic at the same time, and people seeing stuff for them. That's fun.
Yeah, you said like architects, like.
Yeah,
so planning with
architects,
your clients.
this
We'll
is
fix it right now.
right on the spot.
Okay, a few questions maybe here. I don't
Oh,
look
and-
forward to commute.
Not yet.
I don't look forward to commuters now deciding to use AR headset to do the work. It means like the boss or something.
So on that, I guess there's nothing like virtual conflicts.
Merge conflict.
Well, that's what Omniverse is supposed to solve. I mean, it's very similar to what we've had for years in software development. It's just all the merge conflict resolution software. So there is probably merge conflicts at some point, but that's what they're supposed to solve. I'm sure something.
It can sometimes, like I can really find the same file.
So,
But
yeah.
then you can create, see, he said earlier that you can create like, save it on the Omniverse, the whole scene. So nothing really was disturbed outside of this. And then you can go back to like versions.
Oh, so you can even, okay, so it's literally like a version control.
Yeah.
Yeah.
Same
Or
thing.
control, yeah.
Yeah,
Yeah, you probably won't have like two people working on textures at the same time unless you're
You
doing
could.
parts, but.
you wouldn't want to, probably,
exactly.
but you could.
Everybody probably have a
Yeah.
sign.
It allows you. There is the, just like in other version controls, you can lock files, which is usually what artists do. They lock a file, so if I'm working on it, the other person doesn't by mistake edit the same exact file. But you could, if you wanted to. There's no, that's what Omniverse is supposed to do. That's because everything is in real time. The problem is that most of these applications that we're working on, we're doing some sort of action with the application, but it's not what the final product is going to be. The application then has to take whatever you're working on and saving it in memory, and then it's going to process it and going to create the actual asset. So when you're working in something like Photoshop, that what you're doing is getting saved in memory, but what's going to get saved to the file is something that's going to be processed, right? So that's why you can have those merge conflicts. But this is all real time. So there's what you do is what you see. There's no middle process. So everything, there's nothing cached. Everything is just straight going to the nucleus and saving there. And that's because GPUs have all the video RAM and all the stuff that you can use to do that, which is very fast, which your CPU doesn't really have that, at least not to the level that a GPU can. For the consumer, absolutely not. For the enterprise, it used to be where CPUs could do that for the enterprise, but now NVIDIA is dominating the whole, at least the digital side of it, the large data stuff. So, and yeah, and the last thing is Arthrex is hiring. I said I was a senior software engineer for Arthrex. So my team is hiring and other teams at Arthrex are hiring people. We work in medical visualizations, products for the OR to help surgeons. Lots of digital content. We have a whole AR department now. So people creating AR applications for the OR. And we have other visualizations for medical education, things like future, like virtual surgeries and things like that. And those are the type of people we hire. We hire software engineers, entry or senior. We also have lots of technical artists and animators.
What skills are you looking for in XR development? What tech stack do you use? Also for tech art, what pipeline?
So I think for technical artists, we just want to make sure that you have that it's mostly if you have a general knowledge and you've got a good portfolio for the artist and you have general knowledge of a lot of the latest software, just doesn't really matter what it is as long as you're up to date in the industry. It's mostly about how you work with other teams. So can you work with the programmers, can you work with animators, and can you kind of be that middle person that connects the technical side with the artist?
Is that like, it's not remote, right? Is it remote? Like that?
It could be remote, some of them are remote.
Is it like?
I
full-time
didn't
or
specify
flexible?
yeah, these are all full-time.
What kind of tech stack are you guys using in engineering?
In the AR side, this is.
No, in software engineering.
Yeah, so software engineering, this is real-time software engineering. So they're all related to XR, AR. So the specific things, there's other like engineering jobs at Arthrex. You can look up on the website. I can only speak to the graphic related